Hello everyone, it's Snap. Today we're going to talk about brilliance, and we're going to go through introduction to function. So let's get in real quick. Let's get in. Yeah. So instant get in to the question, some question. So there's new skills, so they give me new things. So first, which rule would produce these output from these inputs? Huh, wait, is I'm going back to the first lesson? Because it look like I am. Oh yeah, I'm doing good. Just for a check.
You can identify functions from examples. Now, let's narrow down which rule fits when multiples seem to work.
So I have
Which rule could produce these outputs?
Sheep and tiger is true, and bird and fish is false. So it's like first one. More than 4 letters is true, and less is maybe is that correct? Because there's more than 4 letter on the true, and there's less like the same 4 letter on the false. So literally the first one's correct.
Perfect.
Perfect.
Now, which other rule could also produce the same outputs from these inputs?
Another one. Contain a vowel, but the fish does. Contain an I, but the fish do as well. Contain an E, but the fish don't. So maybe that's the correct answer.
Let's narrow it down. Which rule still works if eel maps to true?
I think because the last one it's just adding in and say true. So it's gonna be more than 4 letters because it's 3 and it must contain an E. It is containing 2 E.
Nice. Here's what's happening. Now, let's try this with numbers instead of words.
So it's like subtracting because 11 to 1, 12 to 2, 13 to 3, and 14 to 4. You might think it's a second letters, but there are no second letters in here. So it must be subtracting some numbers. So here we remove the divide by 5 and 6. We left with subtract 10 and subtract 11. So let's go with subtract 11. 11 subtract 11 equals 0. And it's say 1, so it's wrong. So it must be subtract 10.
Boom. Same inputs and outputs, but can a different rule also produce them?
Okay, 11 go to 1, 12 go to 2, 13 go to 3, and 14 go to 4. Okay, first we have a first, answer is remainder after division by 3. So 11 have a remainder after division by 3, but 12 don't. So I don't think it's division by 3. Now remainder after division by 4. So all of them, not all, like 12 also can divide by 4, so it don't have a remainder. So this is wrong. Remainder after division by 5 seem correct because none of these can't divide by 5 and they have remainder of 1, 2, 3, and 4. So it must be correct.
That's right. Now add one more data point. Which rule still works if 15 maps to 0?
Subtract 10. Oh no. Remainder after division by 5.
You got every single one. Nice. So, here's what I want you to notice. Each input-output pair gives us more information about the rule. See what I mean?
Yeah. Yeah.
So, what do you think the rule is? Pick any input and its output. What's the connection?
Connection? What's the connection? 11 to 0. I don't really know. Let's go to the next one. Skill check.
Now, check your understanding with a few quick problems.
So, I have the input of 11 and go back to 1. That's a lot subtract by 10 again. Because 12 go to 2, same one. 17 go to 7 and 18 go to 8. So that can be divided by 5 and remain after division by 5 as well. Subtract 15 do not make sense because 11 is less than 15. So subtract by 10 is correct. This one. 11 go to 1 back. And you might say, oh, what's it? So we can say last digit now. So that might be correct because it can't be first digit. Because the first input would be correct, but the second to the end will be wrong. And last digit is correct. Some digit also not correct. Because here 11, 1 plus 1 equals 2, not equal 1. Differences between digit is also wrong. So I click last digit. Last one. So I have input of 5 and go to negative 5. 11 go to 1, 12 go to 2, 17 go to 7, 18 go to 8, and 23 go to 13. So some look like last digit me, some might look like, but subtract 10 is better because 5 subtract by 10 equals negative 5. And 11, all those do the same. So this is correct. Oh, Black String TV. Here. Okay, that's all my lesson. I hope you enjoyed. Bye. See you next time.